2011, the year that witnessed the Drexel Ride enter a new sanctuary. Here she would be taken care of and raised to become a center of learning. Discontinued as an amusement park ride, this motion platform was donated to Drexel University for its potential in human factor and game research. Over its lifetime at Drexel, various specialists in the fields of computer science and computer engineering have collaborated in attempting to understand the working of this 2.5-ton machine.
Hello, I'm part of an interdisciplinary senior design team of mechanical and electrical engineers who are researching motion platforms. We are collaborating with Dr. Paul Diefenbach, the co-director of the Drexel Replay Lab, on a motion platform called the Drexel Ride. Under the guidance of our advisor Dr. B.C. Chang, we had to develop a product that allows for realistic simulation of almost any motion-based environment.
The Drexel Ride resembles an ordinary Jeep on the outside, but on the interior a large projection screen and sound system immerse the rider in a virtual reality. The passengers experience heave, pitch, and roll motions, each controlled by a hydraulic actuator. The Drexel Ride was originally controlled by a motion computer that acted as a black box. To be able to adapt the ride for a variety of applications, we are establishing a new system that uses a control and monitoring device to replace this black box.
The hydraulic pump here creates the necessary pressure, causing a flow that transmits power from the prime mover to the hydraulic actuator via a spool valve. Here is one of the 3 spool valves that control the direction and flow rate of the hydraulic fluid tuned from the actuators. The actuators mounted to the arm and base control the heave, pitch, and roll motions. This electrical panel has a set of relays and analog and digital inputs and outputs that connect the components to this motion computer.
The next step in dynamic modeling process is to understand the time response of each of the actuators. Measuring actuator lengths with respect to time for different test signals will help in the creation of a transfer function that represents the dynamics of the system. Feedback sensor values will be utilized, and PID controllers will be implemented. These reduce the error margins, thereby increasing the accuracy of motion.
Meticulous research deemed a data acquisition, control, and monitoring device necessary. A generous donation by National Instrument led to the procurement of this device. This compact radio has 2 modules that serve as digital inputs and outputs, and 2 modules that serve as analog inputs and outputs. This is to replace the current black box that controls the system, giving the user complete freedom to generate any motion required. Some of our hardest and most time-consuming challenges have been those of communication. Constant contact with our donors and also the teams that have worked on this project was essential for progress in this endeavor.
Video game world has gone from 2D side-scrollers to massive 3D online worlds to haptic feedback interaction to games controlled entirely by your body movements. The Drexel Ride provides a new level of immersion by allowing the user to experience all the motions that their character does. By tapping into the potential of the Drexel Ride and allocating resources into this project, Drexel University has the opportunity to become a premier research facility in the emerging industry of motion gaming. The Drexel Ride is being transformed into a motion research platform. This transformation can be done with little or no capital investment, as the ride and the control interface device were donated by ETC and National Instruments respectively. Our team members specialize in dynamic motion, control systems, and electrical signal systems. The combined knowledge and collaborative effort of our engineers make us the perfect team to implement a system that understands the motion and controls the ride.
Our system will allow the researcher to simulate a moving environment as required. This environment can be singular or a combination of heave, pitch, and roll motions. This can be used to produce research that investigates human behavior impacted by various motions or forces. Comprehending the diverse factors that influence human perceptive capabilities under the effects of these forces require the collection and analysis of multiple motion data. Applications could include the investigation of fear factor in motions such as crash tests, and can measure the heartbeat, blood pressure, or adrenaline in roller coaster simulations. Researchers will have the flexibility to safely and effectively tailor their experiments according to the necessary conditions and collect all desired feedback sensor data and position data. We hope to deliver an extremely reliable platform to give you an edge by making such an effective technology easily accessible.